So here today I am talking about numerical methods. Equations are two types. First one is algebraic equation and another one is transcendental equation. So I will consider first one algebraic equation. So equation involving algebraic quantities like x, x square, x cube, so on are called algebraic equation. For example, x square minus 4x minus 9 equals 0. X cube minus 2x square plus x plus 1 equals 0. Next, I'll take transcendental equation. So, equation that involving non-algebraic quantities or special function like exponential form, logarithmic form, trigonometric forms or trigonometric functions, logarithmic functions and exponential functions, so on. So are called transcendental equation. Example, here if you have log x into log x minus 1.2 equals 0. Another one is here tan x equals it, we get 2x and e to the power of x plus minus 2 equals 0, so on. Now, why we need numerical methods? So, can you solve this one? X square minus 1 equals 0, or here x minus 1 equals 0. Can you solve this one? So yeah, you can solve. So x is equal to what you get? 1 you'll get, and here x square plus 2x plus 1 equals 0. So by using quadratic formula, so you can use or factorize that one, so you'll get the solution. So x square plus x plus x plus 1 equals 0. So if you take x common, x plus 1 plus 1, if you take 1 common, you get x plus 1 equals 0. So x plus 1 into x plus 1 equals 0. So what you get? X is equal to minus 1 comma minus 1. So you get the solutions. Again, you get e to the power of x minus 2 equals 0. Can you solve? So yeah, you can find direct method. So take e to the power of x is equal to 2 can write. So taking log on both sides, So what do you get here? Log into e to the power of x equals to, so log 2, sorry, this is log 2. So this can be written as x into log e equals log 2. So what is log e? Log e is 1 only, so x is equal to log 2 will get. Now x into log x minus 1.2 equals 0. Here for this problem you don't have direct solution, so we use numerical methods. Here directly you can solve, but very difficult, so for convenient we'll use numerical methods. So suppose if we have uh, integration of 0 to pi, so sin x plus cos x divided by sin x into cos x into dx. So we can't find out the solution easily, so that time you can use the numerical methods to find out the solution, but you will not get exact here exact solution. You will not get exact solution, but approximately you get the solution for these problems. So for few problems you will get an exact solution, and you can find out the uh, here for the numerical integration, numerical differentiation, and in other competitive exams you can use the numerical methods also to solve some problems. And in civil and survey they will use for to find out the area, so in use numerical methods. And in computer science also to write the program they will use the numerical methods. Next, now I will go for finite difference. Now here consider a function y equals f of x. Let x defined as x naught comma x1 equals x naught plus h, x1 x2 equals x1 plus h, x3 equals x2 plus h, so on. Xn equals xn minus 1 plus h be the set of points and h is the common interval, means difference. Here all h is there, right? So this is the common interval. It should be a common interval. The corresponding values of y equals f of x. Y equals f of x can be here written as y naught equals f of x naught, y1 equals f of x1, y2 equals f of x2, so on. Yn equals f of xn. The values of independent variable. The values of independent variable means here it is x is called the argument. and the corresponding functional value is known as entry. So you have to remember this one. So they will ask for 1 month. What is argument and what is entry? So next year here in finite difference you will get two types. One is forward difference and another one is backward difference. Now I will talk about forward difference. First one, forward difference. Here. The first forward difference of f of x denoted by delta f of x is defined by the equation that is delta f of x can be written as f of x plus h minus f of x. So here you have to remember this one. This is very important. And here forward difference is always denoted by delta. Remember this one is delta. Now here here up to n you have to take here. So here you have to construct the table. So up to n here x0, x1, x2, x3 up to xn you can take on the table, but I will take only example for this one. So I will construct the table. Afterwards I will tell you how will you get those elements. So here I will construct forward difference table. So here x0, x1, x2, x3, x4, x5, and here y can be written as here y0, y1, y2, y3, y4, y5. Here I told you now up to x to the power of n you have to take, but I will take only examples up to x to the power of x suffix 5. Now here forward always it is denoted by delta, so you have to take difference. Now here I have to start with top here. So here y1 minus y0. So delta y0 equals y1 minus y0, and here delta y1 equals y2 minus y1, and here I have to take this difference delta y2 equals y3 minus y2, and here you have to take these two difference means delta y3 equals y4 minus y3, and here delta y4 equals y5 minus y4. Now here these are all called first difference. These are all called first difference. Now delta square, here power 1 is there, so this is first difference. Here power 2 is there, so these are whatever get elements, those are second difference. Here I am neglecting these things. I am neglecting these things here. So I'll consider only delta y0 and delta y1. So what happened here? Second difference, what you get? Delta square y0 equals this minus this, means delta y1 minus delta y0. And what I get here? Delta square y suffix 1 equals delta y2 minus delta y1. And here these two difference, delta square y2 equals delta y3 minus delta y2. And this difference, what you get? Delta square y3 equals delta y4 minus delta y3. So these are all second difference. So look at here, it is y suffix 5, and here you'll get delta y4, means y5 is eliminated. Here what you get? Delta y4, but what you get here? Delta square y3 is there, so means y4 is empty. Last term is eliminated here. So next what you get here in third difference? So here also I am neglecting these terms. When doing problems, you know why you are neglecting. So here what I get? Here delta square delta cube y0 equals, what you get? Delta square y1 minus delta square y0. And here these two difference, what you get? Delta cube y1 equals delta square y2 minus delta square y1. And here these two difference, what you get? Delta cube y2 equals delta square y3 minus delta square y2. So look at here, delta square y suffix 3 is there, but here delta cube y suffix 2. So this term is eliminated now. This term is eliminated. So here also I am neglecting these two terms. So what I get here? Fourth difference here, delta to the power of 4. Let us take these two difference, means delta to the power of 4 y0 equals, here this minus this. So what you get? Delta cube y suffix 1 minus delta cube y0. And here these two means delta to the power of 4 y suffix 1 equals delta cube y suffix 2 minus delta cube y suffix 1. So here this term is eliminated. So look at here, in lastly what you get here? Delta to the power of 5. So what you get? Delta to the power of 4 5 y0 equals, what you get? Delta to the power of 4 y suffix 1 minus delta to the power of 4 y suffix 0. So this is the forward table. So you have to remember here this. Now the first entries in the table, or what do you get? First entries in the table here, delta y0, delta square y0, delta cube y0, comma delta to the power of 4 y0, delta to the power of 5 y0, or so on, are called leading forward differences. leading forward differences. Now here, look at here. How we get this one? Delta y naught equals y suffix 1 minus y naught. So how will you get means here using the definition. So how will you get delta? Here I'll put x equals x naught. X equals x naught. So what you get? This becomes x naught. F of x naught equals what you get here? F of x naught plus h minus f of x naught. So delta f of x naught equals, here look at here, x naught can be written as what? X1. So this becomes f of x1 minus f of x naught, because f of x naught plus h equals x1. Now how do you get del here? F of x naught can be written as y naught, f of x1 can be written as y1. So substitute there. So what do you get? F of x naught can be written as y naught equals f of x1 can be written as y1 minus f of x naught can be written as y naught. Means here delta y naught equals y1 minus y naught. So using the definition, we will get these elements. So these are all the first difference, and these are all the second difference, and these are all the third difference, these are all the fourth, and this one is fifth difference. Now I'll go for next one. Before going to next one, here I'll take the example for forward difference table. Okay. So example, construct a forward difference table for the function f of x equals x cube plus x plus 1, where x takes the values 0, 1, 2, 3, 4, 5, 6, and hence identify the leading forward differences. So solution. Here what are they given? Given f of x equals x cube plus x plus 1. Now here they given x values. Here x takes the values. What do you get here? 0, 1, 2, 3, 4, 5, 6. So put x equals 0. So if you put x equals 0, here 0 cube plus 0 plus 1. So we'll get 1. If you put x equals 1 for the function, what do you get? 1 cube plus 1 plus 1. So you'll get 3. And here if you put x equals 2, here 2 cube plus 1 plus 1. 2 cube means 8, 8 plus 1, 9, 9 plus 1, 10 you'll get. And if you put x equals 3, you'll get 3 cube plus 1 plus 1 equals, here example, first one, construct a forward difference table for the function f of x equals x cube plus x plus 1, where x takes the values 0, 1, 2, 3, 4, 5, and hence identify the leading forward differences. Here given f of x equals x cube plus x plus 1. So where x takes the values, what they given here, 0, 1, 2, 3, 4, 5. Now substitute the x values to function. So f of 0. So f of 0, what I get here, 0 cube plus 0 plus 1 equals 1. So put x equals 1. So 1 cube plus 1 plus 1 will get 3. Put x equals 2. So 2 cube plus 2 plus 1. So you'll get 11. Put x equals 3. So what do you get here? 3 cube plus 3 plus 1. So you'll get 31. X equals, put x equals 4 for this equation. 4 cube plus 4 plus 1. So you'll get 69. So put x equals 5, you'll get 5 cube plus 5 plus 1 equals, if you add all those things, you'll get 131. Put x equals 6, so we'll get 6 cube plus 6 plus 1 equals, you'll get, if you add 216 plus 6 plus 1, you'll get 223. Now construct the table. So here these are all your y values and these are all your x values. So x, y. Here what do you get, x values 0. For 0, what is f of y is equal to f of x. So y of 0, what do you get here, 1. And here for 1 it is 3, and for 2 it is 11, and for 3 it is 31, and for 4 it is 69, for 5 it is 131, for 6 it is 223. Now you have to go for forward table, means you have to use operation is delta. So here you have to start with top. So what do you get, 3 minus 1, you will get 2, and here 11 minus 3, you will get 11 minus 3, you will get 8, and here 31 minus 11, you will get 20, 69 minus 31, you will get 38, 131 minus 69, you will get 62, and here 223 minus 131 will get 92. So delta square, second difference, what we get here, 8 minus 2 will get 6, and here 20 minus 8 will get 12, and 38 minus 20 you will get 18, 62 minus 38 will get 24, and 92 minus 62 will get 30. So delta cube. So here what do you get difference? And 12 minus 6 you will get 6, and 18 minus 12 you will get 6, and here 24 minus 18 you will get 6, 30 minus 24 you will get 6. So fourth difference here, these two difference, 6 minus 6 0, 6 minus 6 is 0, 6 minus 6 you will get 0. No need to find out another differences. Now you construct the further as here, construct the forward difference table. So it's over. Now what do you have to identify now here? Leading the forward difference table. Leading forward difference table means first entries in the table. So look at here, I show here. First entries in the table are called leading forward differences. So here first entries in the table, what do you get? 2, 6, 6. Now to write 0. So 2, 6, 6 are the leading entries, leading forward differences. So next I will go for backward difference.